So welcome to 2017 question B3. This is an intersecting planes question as well as a little bit of a developments question. So we've got the plan and elevation of a display box, and it's shown here on the right. Design is based on a regular hexagonal prism. Okay, so this is a hexagonal prism, or the plan of the hexagonal prism, which is truncated, so which has been cut or sliced. Right, and we can see that in the 3D graphic and in the image here. Pictorial view of the box is also shown. Draw the given plan and make a perspective drawing of the given box, or of the box given the following. Our spectator is 1 meter away from B. So, right, we've got our elevation here, B. So it's going to be straight back 1 meter away from there. Picture plane contains a vertical surface B. So our picture plane is right here, contained on that surface B. Horizon line 1.2 are sloping lines with the surface on A and B and inclined at 15 degrees. Okay, so we're going to probably need an auxiliary vanishing point for those 15-degree slopes. Use auxiliary vanishing points to determine the sloping line of surface on surface C in perspective. Okay, so we need to use auxiliary for that. So first off, let's draw our plan. Draw our plan view of our hexagonal or truncated hexagonal prism. Hexagon, right, just to make sure, that's 60 degrees and 60 degrees, and they've given us the length of one side, which is 0.4 meters. Scale is 1:10, so that is 40 millimeters. That's our side of 40. 60 degrees and 60 degrees. There's our compass. And back at 60 degrees. Alright, heavy. .60 there. Also, there's the top of my hexagon. Okay, so plan drawn. Okay, next they want us to find the spectator. So always try and maybe follow exactly as they say. So we've drawn the plan. Now I want to find the spectator, which is 1 meter away from surface B. So 1 meter away from the center. So 90 degrees away from the center is a little symbol there saying 90 degrees. So halfway along that is 20. I'm going to draw our line down. Okay, so 1 meter, if we convert that 1:10, that's 100 millimeters. So spectator S, and our picture plane is right there, so we don't need to do any bisecting of angles or anything, we know it's right there. So that's our spectator. Our picture plane is there, so let's just extend on our picture plane. We'll find the horizon line is 1.2 above the ground line. So let's see if we can fit that in. Yeah, so fit just about. So there's my ground line. 1.2, which is 1200, or is 112, excuse me, 120 up to my horizon line. So let's move this up slightly so you can see everything. So there's my ground line, horizon line. Okay, now we need to locate the vanishing point. So join. Actually, we don't need to join the outside. We need to go parallel. So parallel to this edge from my spectator. That's at 6 degrees. Parallel to this edge from my spectator. I'll drop those down onto the horizon. Okay, so that's the plan of the vanishing points. This is VP1, VP2. Okay. So let's get the outline of the truncated prism. So we're going to bring all these points back to the spectator. I don't need to bring these two because they're already contained on my picture plane. So I'm going to go straight down. They're contained on the picture plane. The height then, that surface B, we've got the width of it, but transfer down. The height is 0.9 meters, so 90 millimeters. That is surface B, hoodie. Okay, now we're going to use our vanishing points to find surface A and surface C. So surface C and surface A there. So vanish them back to VP1, VP2. Okay, so we've already brought those forward to the spectator. Here's where they intersect the picture plane, so we can drop it down. So that's the outline of A, the outline of C. Let's put that in heavy there. And let's show the back that also. They're going to vanish back. Vanish back. Okay, so that's the outline of the prism. Okay, but it's truncated, so we've got a sloping surface as well, so it's going up. So what we want to do to find that height, we've got the actual height of it here, but that's not contained on the picture plane, so we need to project it forward onto the picture plane. Okay, so we're going to project it forward in the direction that we've used to find our vanishing points. So I'll project this forward so it actually hits this edge, so 6 degrees hits this edge, and I can take the actual true height there, which is 1.9, 0.9 plus 0.8 is 1.2, so it's actually there on our horizon line. Excuse me, 1.9 plus 0.9 plus 0.4 is 1.3, so that's 130. So that's the height. That's my height line there, which I can vanish back to my VP2, and that is going to be the height of the back of the prism. Drop those down. Okay, so that is the outline of my prism. Completed. Yeah, and just to check, I got everything included that's in that pictorial view. Right, so what they want us to do now is the sloping lines on the surface BC are inclined. So here's the position of those lines. Okay, so it's 0.15, so that's 15 mil up. I can draw it horizontally. B is a true shape, so I can actually measure that angle. That is going to be 15 degrees. So that'll find me my next point, but I need an auxiliary vanishing point for there. So let's do everything as far as that. So I can measure a true height of 15, so that will find that point. That's a true height. We've got a true shape of surface B. That will vanish back to my VP2. Next up, I need to measure my angle of 15 degrees. That finds that next height, and we need to now use an auxiliary vanishing point. So the side of the shape that I see the auxiliary, or that sloping 15 degree line, is here, right? Not on this side. So I'm going to use the vanishing point on this side to create that rotating plane or rotating triangular plane down. So beyond this side, measure my 15 degrees. I'm a spectator, 15 degrees. And it's a right angle triangle, so rotating down. So I have my right angle triangle right here. So slide and set squares for that. So that is the height of my auxiliary. Let's put in 15 degrees. That's the height of my auxiliary. Let's get that measured on my compass. That's above VP2, so or VP1. I don't need it for below this point in question, and we can vanish that to my auxiliary vanishing point. So auxiliary VP, and there we have it. Okay, so that is the outline, or the lines on those surfaces at 15 degrees. So we're on to part B. Part B. On a separate diagram, draw a one-piece surface development of surface A, B and C. Include the lines on surface A, B and C in the development. Okay, so this is going to be a nice easy one. We want to draw the development of those surfaces. They're identical surfaces. We have the true shape of B already, so A and C are going to be just connected to it. So let's see. The height is going to be the same, so I'm going to project over that height, there, there, and I'll start my development in this position. So I know this is 40, but I'll just show that it's taken from the same position. That's the true shape. So C, be contained there. We've got B, we've got A. That's the outline of all of those together. So that's going to have our fold lines. Okay, and we know on surface A, that up so you can see it clear. So surface A, it's 15 mil and it's a horizontal line. So we'll go up 15 mil here on surface A, horizontal line, and it turns into this 15-degree sloping line. So measure my 15 degrees from right here. See it there in line with each other, those points of intersection, or where it folds around the B. So that's our development of surface A, B and C, and nice easy development elements to that question.